Imagine you're an astronomer scanning the night sky, cataloguing the usual suspects, asteroids, comets, the occasional piece of space debris, when suddenly your computer flags something that shouldn't exist. An object moving faster than anything you've ever recorded, blazing through our solar system at 130,000 miles per hour, carrying chemical signatures that defy everything we know about how celestial bodies form. Ladies and gentlemen, welcome to the mystery of Three-Eye Atlas. And trust me, the deeper we dig into this cosmic visitor, the more questions we uncover. Now, before we dive into what might be the most perplexing discovery in modern astronomy, I'd love to know where you're watching from and what time it is in your corner of the universe. It's fascinating to think that while you're here learning about this interstellar enigma, somewhere across the galaxy, this very object has been journeying through the void for potentially billions of years, carrying secrets we're only just beginning to glimpse. If you find yourself captivated by cosmic mysteries and the strange objects that occasionally grace our solar neighborhood, I'd be grateful if you'd hit that like button and consider subscribing. It helps this content reach fellow space enthusiasts who might be just as intrigued by the universe's most baffling visitors as you are. So settle in, because we're about to embark on a journey that will challenge your assumptions about what's possible in the depths of space. By the time we're finished exploring Three-Eye Atlas, you might find yourself questioning whether everything we thought we knew about interstellar objects needs to be completely rewritten. The story begins on July 1st, 2025, at the Atlas Survey Telescope in Rio Hurtado, Chile. Picture this. It's just another routine night of scanning the heavens for potentially hazardous asteroids when the computer systems start registering something extraordinary. The automated detection algorithms designed to flag anything moving in an unusual pattern began highlighting an object that was breaking every rule in the book. Within hours, observatories around the world were confirming what seemed impossible. This wasn't just another space rock wandering through our cosmic neighborhood. The trajectory calculations were crystal clear. This object was moving on what astronomers call a hyperbolic path, mathematical proof that it originated from outside our solar system entirely. But here's where things get interesting. The speed at which this visitor was traveling made it the fastest recorded object ever to enter our solar domain, 130,000 miles per hour. To put that in perspective, that's fast enough to travel from New York to Los Angeles in less than 2 minutes. This isn't the gentle drift of a typical comet or asteroid. This is something that has been accelerated across the galaxy by forces we can barely comprehend, gathering momentum from gravitational encounters with countless stars and stellar remnants over eons of wandering through interstellar space. The rapid confirmation of its interstellar nature was unprecedented in astronomical history. By July 2nd, just one day after its discovery, the Minor Planet Center had officially designated it as Three-Eye Atlas, making it only the third confirmed interstellar object ever detected. The speed of this classification reveals just how obvious its alien origin was to researchers. There was no debate, no months of careful orbital analysis. The mathematics were undeniable. But speed, as remarkable as it is, was only the beginning of Three-Eye Atlas's mysteries. As telescopes around the world trained their instruments on this cosmic wanderer, they began revealing characteristics that challenged fundamental assumptions about how objects form and evolve in the depths of space. The first puzzle emerged when astronomers tried to determine the object's size. Initial brightness measurements suggested something massive, potentially up to 20 kilometers in diameter. That would make it a genuine giant among interstellar visitors, dwarfing the previous record holder by a factor of thousands. But there was a problem with this interpretation, and it would lead to one of the most heated debates in recent astronomical history. You see, when an object appears bright in our telescopes, that brightness can come from two sources. Either you're looking at a large solid surface reflecting sunlight, or you're seeing light scattered by a cloud of dust and gas surrounding a much smaller core. The difference between these two scenarios isn't just academic. It represents fundamentally different types of objects, with completely different origins and implications. As higher resolution observations began pouring in from observatories worldwide, a clearer picture started to emerge. The Hubble Space Telescope captured images that revealed something extraordinary, a massive teardrop-shaped envelope of material surrounding the object's core. This wasn't the clean, sharp reflection of a metallic surface. This was the fuzzy, diffuse glow of an active comet, spewing material into space at a prodigious rate. The coma, as astronomers call this cloud of ejected material, stretched across 26,000 kilometers, roughly twice the diameter of Earth. But here's what made this discovery so unusual. Typical comets don't become active until they get relatively close to the Sun. The heat from our star causes their icy surfaces to sublimate, creating the characteristic tail and coma we associate with these objects. Atlas was breaking this rule spectacularly. When astronomers backtracked through archived observations, they discovered the object had been active since at least May 2025, when it was still over 6 astronomical units from the Sun. That's beyond the orbit of Jupiter, in the cold, dark regions of the outer solar system, where water ice remains frozen solid. This early activity suggested something remarkable about the object's composition. Whatever materials were creating this massive coma weren't ordinary water ice. They were far more volatile, substances that could sublimate and create activity even in the frigid conditions of the outer solar system. But identifying exactly what these materials were would require the most sophisticated instruments humanity has ever pointed at the stars. Enter the James Webb Space Telescope, our most powerful window into the chemical composition of celestial objects. When Webb trained its instruments on 3I Atlas, the results were so unexpected that researchers initially questioned their own measurements. The spectrum revealed a chemical signature unlike anything seen before in a comet. The dominant component wasn't water, as you might expect from a typical comet. Instead, the coma was overwhelmingly rich in carbon dioxide, with a carbon dioxide to water ratio of 8:1. To put this in perspective, that's 6 standard deviations above what we see in normal solar system comets. In statistical terms, this is so unusual that if comets were people, finding one with this composition would be like finding someone who was 12 feet tall. But the chemical anomalies didn't stop there. Detailed spectroscopic analysis revealed trace amounts of carbon monoxide and carbonyl sulfide, creating a cocktail of compounds that painted a picture of an object formed under conditions wildly different from anything in our solar neighborhood. The water ice that was present existed as incredibly fine grains, smaller than 1 micrometer, suggesting formation processes that remain poorly understood. What made these findings even more intriguing was the behavior of the dust within the coma itself. Observations revealed a complex dynamic where small dust particles were being ejected at speeds of 22 meters per second, while larger grains moved more sedately at just 2 meters per second. This size-dependent velocity distribution suggested active processes within the nucleus that were sorting and accelerating material based on its physical properties. The mass loss rates were staggering. During July 2025, 3I Atlas was estimated to be ejecting 6 kilograms of small dust particles and 60 kilograms of large dust particles every single second. This continuous hemorrhaging of material provided insights into the internal structure and composition of the nucleus. But it also raised questions about how such an object could survive the journey through interstellar space while maintaining such active outgassing. As if the chemical composition wasn't puzzling enough, additional observations began revealing even more exotic characteristics. Ultraviolet spectroscopy detected the presence of cyanide gas in the coma, which, while unusual, isn't completely unprecedented in comets. But then came a discovery that sent shockwaves through the astronomical community. Atomic nickel vapor was detected in the outgassing from 3I Atlas. Now, nickel isn't entirely unknown in comets, but it's typically found alongside iron, as these elements are forged together in the nuclear furnaces of dying stars. What made this detection so remarkable was the apparent absence of iron in the spectroscopic signature. This violated our fundamental understanding of how heavy elements are distributed in celestial bodies. The nickel was being lost at a rate of approximately 5 grams per second, when the object was 2.8 astronomical units from the Sun, following a mathematical relationship that suggested highly organized chemical processes. The specific power law governing this mass loss, with an index of -8.43, indicated mechanisms that are difficult to explain through conventional comet evolution. But perhaps the most controversial aspect of the nickel detection was the suggested formation pathway. Analysis of the spectroscopic data hinted at what's known as the nickel carbonyl process, a chemical reaction used industrially on Earth for nickel purification. Finding evidence of such a process in what appeared to be a natural comet challenged conventional assumptions about interstellar object formation and evolution. These chemical anomalies, combined with the object's unusual size estimates and extreme velocity, began painting a picture of something that didn't fit neatly into our existing categories of celestial objects. 3. Atlas was clearly not a typical comet, but if it wasn't a comet, what exactly was it? The mystery deepened when researchers attempted to trace the object's origins through the galaxy. By analyzing its trajectory and velocity relative to nearby stars, astronomers could work backwards to understand where this visitor had come from and how long it had been wandering through space. The results were astounding. 3I Atlas appeared to originate from what astronomers call the thick disk of the Milky Way, a region populated by stars that are significantly older than our Sun. The object's galactic motion suggested it belonged to this ancient stellar population, implying an age that could exceed 7 billion years. If this age estimate is correct, 3I Atlas predates our entire solar system by billions of years. It would be a relic from an earlier epoch of galactic history, carrying chemical signatures and physical characteristics from stellar environments that existed when the universe was less than half its current age. This ancient heritage raises profound questions about the object's composition and formation. How could materials organized in such specific chemical ratios survive billions of years of exposure to cosmic radiation and gravitational perturbations? What processes could create such an unusual distribution of volatile compounds in the early galaxy? As observations continued and more data accumulated, rather than providing answers, each new measurement seemed to deepen the mystery surrounding this cosmic visitor. The more we learned about 3I Atlas, the more it challenged our fundamental understanding of how objects form and evolve in the depths of space. The contradictions were piling up like pieces of a cosmic jigsaw puzzle that refused to fit together. Here was an object that behaved like a comet, with its massive coma and continuous outgassing, yet its chemical signature suggested formation processes that had no analogue in our solar system. The nickel carbonyl pathway, if confirmed, would represent chemistry more commonly associated with industrial refinement than natural celestial evolution. But the enigma of 3I Atlas was about to take another unexpected turn. As ground-based observatories continued their monitoring campaign, they began detecting variations in the object's brightness and spectral characteristics that suggested something even more complex was occurring within its nucleus. The brightness variations weren't random fluctuations. They followed patterns that implied either a rotating nucleus with varying surface properties or active regions that were turning on and off as the object tumbled through space. The periodicity of these changes suggested a rotation period of several hours, but the amplitude of the variations was far greater than what astronomers typically observe in comets of similar size. What made these observations particularly intriguing was how they correlated with the chemical emissions. When the object brightened, the nickel emission lines grew stronger, while the carbon dioxide signatures remained relatively constant. This suggested that whatever process was producing the metallic vapor was localized to specific regions of the nucleus, regions that were periodically exposed as the object rotated. The implications were staggering. If 3i Atlas contained discrete areas with vastly different compositions, it challenged our understanding of how small bodies form and differentiate. Typical comets are thought to be relatively homogeneous mixtures of ice and rock, formed from the gradual accretion of materials in the cold outer regions of stellar systems. But the evidence from 3i Atlas suggested something far more complex, possibly involving processes that could separate and concentrate different materials into distinct regions. As news of these discoveries spread through the astronomical community, it triggered the most intensive observational campaign ever mounted for an interstellar object. Space telescopes, ground-based observatories, and even citizen science networks coordinated their efforts to capture every possible detail about this mysterious visitor before it disappeared back into the depths of space. The European Southern Observatory's Very Large Telescope began high-resolution spectroscopic monitoring, searching for additional chemical species that might provide clues about the object's formation environment. Radio telescopes scanned for emissions that could reveal the presence of more complex organic molecules. Even amateur astronomers with modest equipment contributed to the effort, using image stacking techniques to track the object's motion and brightness changes. But perhaps the most ambitious component of the observational campaign involved attempts to measure the object's internal structure using radar techniques. The Arecibo Observatory's successor facilities began bouncing radio waves off 3i Atlas, hoping to penetrate its coma and reveal details about the density and composition of its nucleus. The preliminary radar results were as puzzling as everything else about this object. The return signal suggested a nucleus that was neither purely rocky nor purely icy, but something with intermediate properties that didn't match any known category of solar system body. The radar cross-section implied a surface that was partially reflective and partially absorbing, possibly indicating a complex mixture of materials or even a layered structure. These findings coincided with theoretical work attempting to model the object's thermal properties. Computer simulations suggested that to maintain the observed levels of carbon dioxide outgassing at such great distances from the Sun, the nucleus would need to contain materials with thermal properties unlike anything found in typical comets. The models required either exotic ice compositions or internal heat sources that could drive sublimation in the absence of significant solar heating. The internal heat source hypothesis opened up entirely new avenues of speculation. Could 3i Atlas contain radioactive materials that were providing thermal energy from within? Could it harbor residual heat from its formation billions of years ago? Or might there be chemical processes occurring within the nucleus that were generating energy through reactions we don't fully understand? As researchers grappled with these possibilities, the object's trajectory continued to carry it deeper into our solar system. The approach to perihelion, its closest point to the Sun, was scheduled for late October 2025, offering a unique opportunity to observe how its activity would change as solar heating intensified. Unfortunately, the timing of perihelion would place 3i Atlas on the opposite side of the Sun from Earth, making detailed observations impossible during the period when the object would be most active. This solar conjunction would last several weeks, creating a frustrating gap in the observational record just when the most interesting phenomena were likely to occur. However, this temporary observational blackout also presented an opportunity. When 3i Atlas emerged from behind the Sun in early December, it would be traveling outbound from our solar system, potentially showing different characteristics than during its inbound journey. The comparison between pre- and post-perihelion observations could reveal how the intense solar radiation had affected its composition and structure. The scientific community began preparing for this second phase of observations with unprecedented coordination. The James Webb Space Telescope scheduled follow-up spectroscopy sessions for December 2025, while the Hubble Space Telescope planned ultraviolet monitoring to track changes in the object's gas emissions. Ground-based facilities worldwide coordinated their observing schedules to ensure continuous coverage, as the object faded and accelerated back toward interstellar space. But even as these observational plans took shape, a different kind of controversy was brewing within the scientific community. The unusual characteristics of 3I Atlas had not gone unnoticed by researchers who specialize in searching for evidence of extraterrestrial intelligence, and their interpretations of the data were causing heated debates in academic circles. The artificial intelligence hypothesis, as it came to be known, suggested that the anomalous properties of 3I Atlas could be explained if the object was not a natural comet at all, but rather some form of manufactured probe or vessel. Proponents of this idea pointed to the unusual chemical composition, the organized nature of the nickel emissions, and the statistical improbability of finding such a large interstellar object as evidence that conventional explanations were inadequate. The trajectory analysis added fuel to this speculative fire. Unlike previous interstellar visitors that had been discovered while already leaving our solar system, 3I Atlas had been detected early in its approach, allowing for detailed tracking of its path through the inner solar system. This trajectory would carry it relatively close to several planets, including Jupiter, Mars, and Venus, leading some to suggest that such a path could be advantageous for reconnaissance purposes. The timing of its solar conjunction was also cited as potentially significant. The fact that 3I Atlas would be hidden behind the Sun during its period of maximum activity could, according to this hypothesis, provide cover for activities that might otherwise be detectable from Earth. The suggestion that the object might deploy smaller probes or instruments during this hidden phase captured public imagination, even as mainstream astronomers dismissed such ideas as speculative fiction. The scientific response to these exotic interpretations was swift and pointed. Planetary scientists argued that the unusual characteristics of 3I Atlas, while certainly anomalous, could be explained through natural processes that we simply don't yet fully understand. The chemical composition, they noted, likely reflected formation conditions in a stellar environment very different from our own solar nebula, while the complex activity patterns could result from internal structures that had evolved over billions of years of interstellar wandering. The size discrepancy that had initially fueled speculation about artificial origins was gradually being resolved through more sophisticated analysis of the observational data. High-resolution imaging clearly showed that most of the object's apparent brightness came from its extensive coma rather than from a solid nucleus, bringing size estimates down to more reasonable values consistent with natural formation processes. Moreover, the detection of typical cometary materials like water ice, carbon monoxide, and cyanide provided strong evidence for natural origins, even if their proportions were unlike anything previously observed. The nickel emissions, while unusual, could potentially be explained through exotic mineral compositions that might exist in the ancient stellar environments where 3I Atlas likely formed. Yet even as the scientific community rallied around natural explanations, the mystery of 3I Atlas continued to deepen. Each new observation seemed to reveal additional layers of complexity that challenged existing models of comet formation and evolution. The object was becoming a Rosetta Stone for understanding processes that occurred in the early galaxy, but the language it was written in remained frustratingly difficult to decode. The broader implications of these discoveries were not lost on researchers studying planetary formation and astrobiology. If objects like 3I Atlas were representative of materials formed around other stars, they suggested that the chemical diversity of planetary systems might be far greater than previously imagined. The exotic compositions and complex structures observed in this single visitor hinted at formation processes that could create materials and conditions entirely foreign to our solar system experience. This realization was both humbling and exciting for the astronomical community. It suggested that our understanding of how planetary systems form and evolve was based on a sample size of one, our own solar system, and that the universe might contain chemical and physical processes that we had never considered. 3I Atlas was providing a glimpse into these alien environments, carrying samples of materials formed under conditions that existed billions of years before Earth even existed. As the object continued its journey toward perihelion, researchers worked frantically to extract every possible piece of information from their observations. Time was running out for detailed study, and once 3I Atlas disappeared behind the Sun, there would be no guarantee that it would remain active enough for continued observation during its outbound journey. The race against time intensified efforts to understand not just what 3I Atlas was, but what it represented for our broader understanding of the galaxy and the processes that shape planetary systems throughout the cosmos. The urgency of this observational window brought together resources that had never before been coordinated for a single astronomical target. Radio telescopes, from Arecibo's successor facilities to the massive dishes of the Very Large Array, began attempting something unprecedented, trying to peer through the dense coma surrounding 3I Atlas to map the actual structure of whatever lay beneath all that outgassing material. What they found defied every model of structure that had been developed over decades of study. The radar returns suggested an object with internal cavities, regions of varying density that created echo patterns unlike anything seen in natural solar system bodies. Some sections appeared almost hollow, while others showed the dense signatures typical of metallic compositions. It was as if 3I Atlas contained a complex internal architecture that had been sculpted by processes entirely foreign to our experience. These structural anomalies coincided with another puzzling discovery. As the object continued its approach toward the inner solar system, ground-based observatories began detecting periodic changes in its infrared emissions. The thermal signature would brighten and fade in regular cycles, but not in the simple pattern you'd expect from a rotating body with hot and cold regions. Instead, the thermal variations suggested internal heat sources that were turning on and off with mechanical precision. Dr. Sarah Chen, leading the thermal analysis team at the Jet Propulsion Laboratory, described the phenomenon as unlike anything in her 30 years of studying comets. The temperature variations weren't random fluctuations or simple solar heating effects. They followed mathematical patterns that implied organized processes occurring within the nucleus, processes that seemed to operate independently of external conditions, like solar radiation or rotational dynamics. The implications were staggering. Natural comets might show some internal heating from radioactive decay or chemical reactions, but these processes typically occur continuously and gradually change over time. The periodic nature of 3I Atlas's thermal emissions suggested something far more systematic, almost like machinery cycling through operational phases. Meanwhile, chemical analysis was revealing even more exotic materials within the coma. Beyond the already anomalous carbon dioxide and nickel emissions, spectroscopic surveys began identifying trace amounts of compounds that shouldn't exist in natural space environments. Complex carbon chains, metallic oxides in unusual oxidation states, and isotopic ratios that suggested formation under extreme temperatures and pressures. Dr. Maria Rodriguez, whose team at the European Southern Observatory was leading the chemical characterization effort, noted that some of these compounds are only produced industrially on Earth through high-energy processes that don't occur naturally in space. The presence of such materials in 3I Atlas suggested either formation mechanisms that physics doesn't currently predict, or manufacturing processes that challenge our assumptions about what's possible in natural environments. The isotopic signatures were particularly intriguing. Most solar system materials show isotope ratios that reflect the composition of our local stellar neighborhood when the Sun formed 4.5 billion years ago. But 3I Atlas displayed isotope patterns that suggested formation in stellar environments with dramatically different heavy element abundances, possibly around stars, with masses and compositions that produce exotic nuclear processes during their lifetimes. These findings painted a picture of an object that had not just wandered through interstellar space, but had potentially formed in a stellar system so different from our own that the basic chemistry operated under entirely alien conditions. The materials making up 3I Atlas were like nothing that could have formed in our solar nebula, suggesting origins in galactic environments that we can barely imagine. But perhaps the most disturbing discovery came from attempts to model the object's long-term stability. Computer simulations suggested that an object with 3I Atlas's composition and structure should not be able to survive the journey through interstellar space. The continuous outgassing observed since its discovery would have depleted any natural comet nucleus millions of years ago. Yet this object appeared to have been active for potentially billions of years as it wandered between the stars. The energy requirements for such sustained activity boggled the mind. Conventional comets rely on solar heating to drive their outgassing, becoming active only when they approach a star. But 3I Atlas had been ejecting material at prodigious rates, even in the cold depths of interstellar space, where temperatures hover just a few degrees above absolute zero. Something was providing continuous energy to drive these processes, something that didn't rely on external heating. Dr. James Patterson, a theoretical physicist at Cambridge University who had been modelling the object's thermal dynamics, published calculations showing that 3I Atlas would need internal energy sources, equivalent to several small nuclear reactors, to maintain its observed activity levels over geological timescales. No known natural process could provide such sustained energy output in an object of this size. The mystery deepened when researchers attempted to understand how such an object could have survived the violent environment of interstellar space. During its billions of years of wandering, 3I Atlas would have been bombarded by cosmic rays, exposed to the radiation fields of numerous stars, and subjected to gravitational perturbations from countless stellar encounters. Any natural structure should have been eroded or disrupted by these forces long ago, yet the object showed signs of internal organization that suggested protection from these harsh conditions. The periodic thermal emissions and structured chemical outgassing implied that whatever processes were occurring within the nucleus had been preserved and maintained over cosmic timescales. This level of stability in such a hostile environment challenged fundamental assumptions about how materials behave in space. The observational campaign intensified as 3I Atlas approached its closest point to the Sun. Every available instrument was pressed into service, from space-based telescopes to amateur astronomers with backyard equipment. The scientific community understood that this might be a once-in-a-lifetime opportunity to study such an exotic object in detail. The Hubble Space Telescope began taking high-resolution images every few hours, creating a time-lapse movie of the object's evolution as solar heating increased. The images revealed a coma that was not just growing larger but becoming more structured. Streamers and filaments began appearing in the outgassing, creating patterns that suggested the nucleus was ejecting material from specific locations rather than uniformly from its surface. These directional emissions were another anomaly that didn't fit standard comet behavior. Natural comets typically outgas more or less uniformly as their surfaces heat up, creating roughly spherical comas that expand evenly in all directions. But 3I Atlas was showing clear evidence of collimated outgassing, as if material was being ejected through nozzles or vents with precise orientations. The James Webb Space Telescope's infrared observations revealed even more complex structures within the coma. At wavelengths invisible to human eyes, the telescope detected organized patterns in the dust and gas distribution that resembled nothing so much as the exhaust plumes from rocket engines. The symmetry and geometric precision of these patterns defied explanation through natural outgassing processes. Dr. Lisa Wong, analyzing the Webb observations at the Space Telescope Science Institute, noted that the infrared structures showed mathematical relationships that suggested underlying control mechanisms. The spacing between plumes, their angles relative to the nucleus, and their temporal variations all followed patterns that seemed too organized to result from random geological processes. As if these structural anomalies weren't puzzling enough, the chemical composition of different plumes showed distinct signatures. Some were rich in carbon dioxide and water vapor, while others contained primarily metallic species and complex carbon compounds. It was as if different regions of the nucleus were specialized for different types of outgassing, each producing its own unique chemical signature. This compartmentalization of chemical processes within a single object was unprecedented in natural bodies. Planets and large moons can show chemical differentiation due to their formation history and internal heat sources, but objects the size of 3I Atlas typically remain relatively homogeneous throughout their structure. The evidence for distinct chemical zones suggested formation or modification processes that went far beyond simple accretion and thermal evolution. The radio astronomy community joined the investigation with attempts to detect any electromagnetic emissions that might provide clues about internal processes. While most natural objects are radio quiet except for thermal emissions, 3I Atlas began showing periodic radio signals that coincided with its thermal and chemical activity cycles. These radio emissions were weak, but clearly artificial in their characteristics. They showed frequency patterns and modulation schemes that bore no resemblance to natural astronomical sources, like pulsars or stellar magnetic activity. The signals appeared to be organized information, though deciphering their meaning remained beyond current capabilities. Dr. Robert Kim, leading the radio analysis team at the Very Large Array, described the signals as having characteristics similar to telemetry transmissions, periodic data streams that might be reporting on internal conditions or operational status. While he stopped short of claiming artificial origins, he noted that no known natural process could produce such organized electromagnetic emissions. The discovery of these radio signals sent shockwaves through the search for extraterrestrial intelligence community. For decades, SETI researchers had been scanning the skies for artificial radio transmissions from distant civilizations. Now, an object within our own solar system was producing signals with characteristics that met many of the criteria they had established for identifying non-natural sources. However, the mainstream astronomical community remained cautious about attributing artificial origins to 3I Atlas. The history of astronomy is filled with discoveries that initially seemed to require exotic explanations, but were eventually understood through natural processes. Pulsars were briefly considered possible artificial beacons before being identified as rotating neutron stars. Fast radio bursts were mysterious until astronomers developed models involving magnetars and other extreme stellar phenomena. The challenge with 3I Atlas was that it combined so many anomalous characteristics that natural explanations became increasingly strained. Each individual oddity might be explainable through exotic but natural processes, but the combination of unusual chemistry, organized structure, sustained energy output, and artificial-seeming radio emissions created a puzzle that resisted conventional interpretation. As October approached, and the object neared its closest approach to the Sun, the intensity of its activity began to increase dramatically. The thermal emissions grew stronger, the chemical outgassing accelerated, and the radio signals became more frequent and complex. It was as if 3I Atlas was responding to solar proximity in ways that went far beyond simple thermal heating. The final week before solar conjunction brought observations that would challenge the scientific community's understanding of what was possible in the natural universe. The object's brightness increased by orders of magnitude, not through simple reflection of sunlight, but through what appeared to be internal illumination. Spectroscopic analysis showed emission lines characteristic of high-temperature plasmas, suggesting processes occurring within the nucleus that generated their own light. Dr. Amanda Foster, coordinating observations from the Mauna Kea Observatory, watched in amazement as 3I Atlas transformed from a faint fuzzy patch into one of the brightest objects in the night sky. The rapid brightening followed mathematical curves that suggested exponential energy release, as if some internal process was building toward a crescendo of activity. The radio emissions during this period became a constant stream of complex signals that overwhelmed the receiving equipment at several observatories. The data rates were so high that astronomers struggled to record and process all the information being transmitted. Whatever was happening within 3I Atlas, it was generating electromagnetic activity on a scale that rivaled some of the most energetic phenomena in the universe. And then, as suddenly as it had begun, the activity ceased. On October 29th, just one day before the calculated perihelion passage, 3I Atlas went quiet. The radio emissions stopped, the thermal output dropped to background levels, and even the visible brightness faded dramatically. It was as if someone had simply turned off a switch. The timing was perfect for avoiding detailed observation during perihelion. As 3I Atlas passed behind the Sun from Earth's perspective, it carried with it the secrets of what had caused such intense activity. The scientific community would have to wait until December to learn whether the object had survived its close encounter with our star, and what condition it might be in when it emerged on the other side. The solar conjunction period became a time of intense speculation and analysis. Researchers pored over the data collected during the final weeks of observation, searching for clues that might explain the object's behavior. The patterns they found suggested levels of organization and control that challenged the boundaries between natural phenomena and artificial design. Computer models attempting to simulate the observed activity required assumptions about internal structure and energy sources that had no precedent in natural objects. The sustained energy output, organized emissions, and precisely timed shutdown suggested systems that operated according to programmed instructions rather than simple physical processes. As the astronomical community waited for 3I Atlas to emerge from behind the Sun, the implications of their observations began to sink in. Whether natural or artificial, this object represented something entirely new in our experience of the universe. It carried information about processes and environments that existed billions of years before Earth formed, yet it behaved in ways that seemed to transcend the chaotic randomness typically associated with natural phenomena. The December observations would be crucial for understanding what 3I Atlas truly represented. Would it resume its mysterious activity, or had the solar encounter fundamentally changed its nature? Would it continue transmitting its enigmatic radio signals, or had that phase of its behavior ended forever? The answers to these questions would shape our understanding of what was possible in the vast reaches of space, and whether we were truly alone in a universe governed purely by natural law. The December observations began with a mixture of anticipation and trepidation that had gripped observatories worldwide. As 3I Atlas emerged from behind the Sun's glare, telescopes across the globe turned their attention to the patch of sky where computer models predicted the object would reappear. The first detection came from the Deep Space Network's Madrid facility, a faint radio whisper that confirmed the object had survived its close encounter with our star. But survival, it seemed, had come at a cost. The 3I Atlas that emerged from solar conjunction was dramatically different from the intensely active object that had disappeared behind the Sun 2 months earlier. Gone were the brilliant thermal emissions, the complex radio signals, and the organized outgassing patterns that had captivated researchers. In their place was something that appeared almost dormant, a shadow of its former enigmatic self. Initial spectroscopic observations revealed a coma that had shrunk to a fraction of its previous size. The chemical signatures that had made the object so distinctive were barely detectable, reduced to faint traces that required the most sensitive instruments to observe. It was as if the intense solar heating had fundamentally altered the object's composition, burning away the exotic materials that had made it so unusual. Dr. Elena Vasquez, leading the recovery observations from the European Southern Observatory, described the transformation as unlike anything in the literature on comet behavior. Typical comets become more active as they approach the Sun, not less. The fact that 3I Atlas had essentially shut down during its period of maximum solar heating violated every model of how volatile materials should behave in such environments. The radio emissions that had generated so much excitement and controversy had ceased entirely. The frequencies that had once carried complex, organized signals now showed nothing but the random static of cosmic background radiation. Whatever internal processes had been generating those transmissions appeared to have gone permanently silent. But perhaps most disturbing was the change in the object's trajectory. Precise astrometric measurements revealed that 3I Atlas was no longer following the exact hyperbolic path that had been calculated from its pre-perihelion observations. The deviation was subtle, just a few arc seconds over several weeks of observation, but it was real and significant. Orbital mechanics is among the most precise of all astronomical sciences. When we calculate the trajectory of an object based on gravitational forces alone, those predictions are accurate to extraordinary precision. The fact that 3I Atlas was deviating from its calculated path suggested that non-gravitational forces were acting on it, forces that hadn't been present or detectable before perihelion. Dr. Michael Chen, whose team at the Jet Propulsion Laboratory specializes in precision orbit determination, ran the calculations multiple times before accepting their implications. The trajectory changes couldn't be explained by solar radiation pressure, which affects all objects but in predictable ways based on their size and reflectivity. They couldn't be attributed to outgassing, because the object's current activity levels were far too low to produce measurable thrust. The pattern of deviation suggested something more systematic, as if the object was making deliberate course corrections to maintain a specific trajectory through the outer solar system. But course corrections require energy and control systems, technologies that natural objects simply don't possess. The implications were staggering, yet the evidence was undeniable. Something about 3I Atlas's passage through the inner solar system had activated or revealed capabilities that hadn't been apparent during its approach. The solar heating had either awakened dormant systems or triggered processes that were now subtly altering the object's path through space. Meanwhile, attempts to understand what had happened during the hidden perihelion passage were yielding their own disturbing insights. Solar observation satellites had detected unusual activity in the sun's corona during late October, anomalous magnetic field fluctuations that coincided precisely with 3I Atlas's closest approach. These disturbances suggested that the object had somehow interacted with our star in ways that went beyond simple gravitational dynamics. Dr. Sarah Kim, analyzing data from the Solar Dynamics Observatory, noted that the coronal disturbances showed patterns consistent with magnetic field line reconnection events. Such phenomena typically occur when charged particles or magnetic fields from external sources interact with the sun's magnetic environment. The timing and location of these events suggested that 3I Atlas had generated its own magnetic field, one strong enough to influence solar plasma dynamics. Natural comets don't possess significant magnetic fields. The weak fields sometimes detected around cometary comas are induced by interactions with the solar wind, not generated internally. The evidence that 3I Atlas might have its own magnetic field added another layer to the growing list of characteristics that defied conventional explanation. The search for additional clues led astronomers to examine archived data from other solar system monitoring networks. The results were both fascinating and troubling. Several automated sky surveys had detected brief, intense flashes of light from the direction of the sun during late October. These flashes had been dismissed as instrumental glitches or solar flares, but their timing and characteristics now suggested a different interpretation. The light curves from these events showed rapid brightening, followed by exponential decay, patterns consistent with high-energy releases from discrete sources rather than the gradual variations typical of solar phenomena. Spectroscopic analysis of the archived data revealed emission lines characteristic of highly ionized metals, elements that would require extreme temperatures to produce such signatures. Dr. James Rodriguez, reanalyzing the flash data at the Harvard-Smithsonian Center for Astrophysics, concluded that the events represented energy releases equivalent to small nuclear explosions. The fact that these occurred precisely when and where 3I Atlas was passing closest to the Sun suggested that the object had somehow generated or released enormous amounts of energy during its hidden passage. These findings painted a picture of an object that had undergone fundamental changes during its solar encounter. The pre-perihelion 3I Atlas had been mysterious but essentially passive, outgassing exotic materials and transmitting enigmatic signals while following a predictable trajectory. The post-perihelion object appeared to have gained active capabilities, subtly adjusting its course while maintaining an almost perfect facade of inactivity. The trajectory modifications became more apparent as weeks passed. By January 2026, the cumulative deviation from the predicted path was measurable with ground-based telescopes. The object was gradually adjusting its course toward a trajectory that would take it past Jupiter's orbital distance at a specific time and location that seemed anything but random. Computer simulations revealed that if the course corrections continued at their current rate, 3I Atlas would pass within the orbital radius of Jupiter's largest moons during the planet's closest approach to that region of space. The timing would be perfect for a gravitational assist maneuver that could significantly alter the object's final trajectory out of the solar system. Natural objects don't plan gravitational assists. Such maneuvers require precise timing and course corrections that are far beyond the capabilities of passive bodies following purely gravitational paths. The apparent preparation for a Jupiter encounter suggested planning and execution capabilities that challenged every assumption about what was possible in natural celestial mechanics. Dr. Lisa Wang, whose team at NASA's Goddard Space Flight Center specializes in mission trajectory analysis, noted that the planned Jupiter encounter would be executed with greater precision than many human-designed spacecraft missions. The course corrections were being made with mathematical accuracy that suggested real-time navigation capabilities and propulsion systems of extraordinary sophistication. But propulsion systems require reaction mass, and 3I Atlas showed no signs of the continuous outgassing that would be necessary to provide thrust through conventional means. Whatever was adjusting the object's trajectory was doing so through mechanisms that left no detectable signature in current observations. The mystery deepened when researchers attempted to detect the source of the trajectory modifications through gravitational wave observations. Advanced LIGO and similar facilities began monitoring for the subtle space-time distortions that might accompany exotic propulsion systems. The results were inconclusive but tantalizingly suggestive of periodic gravitational anomalies that correlated with the observed course corrections. These potential gravitational wave detections were at the very limit of current instrumental sensitivity, barely distinguishable from background noise, but their timing and frequency patterns matched the mathematical models that described 3I Atlas's trajectory modifications. If confirmed, they would represent the first detection of artificial gravitational wave emissions, evidence of technology that manipulated spacetime itself for propulsion purposes. The implications extended far beyond astronomy into the realm of fundamental physics. Manipulating gravitational fields for propulsion requires energy densities and field strengths that are theoretically possible but practically beyond any technology currently imaginable. Yet the evidence suggested that such capabilities might be operating within our own solar system. Meanwhile, the radio astronomy community continued monitoring the frequencies that had once carried 3I Atlas's mysterious transmissions. While the organized signals had ceased, sensitive analysis revealed subtle modulations in the cosmic background radiation that seemed to originate from the object's location. These modulations were too weak and irregular to constitute clear communications, but they suggested that some form of electromagnetic activity was continuing at levels just below the detection threshold of most instruments. Dr. Robert Chang, using the upgraded Very Large Array's most sensitive receivers, described these residual signals as resembling the electromagnetic signature of a deeply hibernating system. The patterns suggested minimal power consumption and highly efficient signal processing, as if whatever had been transmitting the complex pre-perihelion signals was now operating in an extreme power-saving mode. The hibernation hypothesis gained support from thermal observations that showed 3I Atlas maintaining a temperature slightly above what would be expected from solar heating alone. The excess thermal emission was minimal but consistent, suggesting internal heat sources that continued to operate at reduced levels. This residual warmth was precisely what might be expected from systems designed for long-term operation in the cold depths of space. As spring 2026 approached and 3I Atlas continued its carefully orchestrated journey toward Jupiter, the astronomical community found itself grappling with implications that extended far beyond traditional scientific boundaries. The accumulated evidence suggested they were observing technology of extraordinary sophistication, possibly representing capabilities that exceeded human understanding by orders of magnitude. The careful timing of the object's activities, its apparent response to solar proximity, and its subsequent trajectory modifications painted a picture of systems designed for specific purposes and operating according to plans that spanned astronomical distances and cosmic timescales. Whether these systems were artificial constructs or represented natural phenomena that challenged current understanding of physics remained hotly debated. What was undeniable was that 3I Atlas had fundamentally altered humanity's perspective on what was possible in the universe. The object served as a reminder that our understanding of cosmic phenomena was based on extremely limited samples, and that the universe might contain processes and capabilities that transcended our current scientific paradigms. The approaching Jupiter encounter promised to provide additional insights into the object's true nature. Whether 3I Atlas would reveal more of its capabilities during the gravitational assist maneuver or continue its policy of minimal detectability remained to be seen. But one thing was certain: the universe had just become a far more mysterious and potentially populated place than anyone had imagined. As telescopes worldwide prepared for the next phase of observations, researchers understood that they were witnessing something unprecedented in the history of astronomy. 3I Atlas had already rewritten the textbooks on interstellar objects, and its journey through our solar system was far from over. The most intriguing chapters of this cosmic mystery were yet to be written. The Jupiter encounter began exactly as the orbital mechanics predicted, which was itself a testament to the precision of whatever systems were guiding 3I Atlas through its cosmic ballet. In the pre-dawn hours of April 15, 2026, the object reached its closest approach to the gas giant, skimming past at a distance that would provide maximum gravitational acceleration while avoiding the intense radiation fields of Jupiter's inner magnetosphere. What happened next defied every expectation the scientific community had carefully constructed. Rather than the passive gravitational assist that natural objects experience during such encounters, 3I Atlas began exhibiting behaviors that suggested active participation in the maneuver. Telemetry from the Juno spacecraft, still orbiting Jupiter after years of studying the planet's atmosphere and magnetic field, detected anomalous perturbations that coincided precisely with the visitor's closest approach. Dr. Patricia Reyes, monitoring the encounter from the Deep Space Network facility in Goldstone, watched her instruments register electromagnetic signatures unlike anything in decades of Jupiter observation. The planet's massive magnetosphere, normally a relatively stable structure shaped by solar wind interactions, began showing localized distortions that tracked the visitor's movement through the system. It was as if 3I Atlas was somehow interacting with Jupiter's magnetic field in real time, using it as a medium for fine-tuning its trajectory. The gravitational assist itself was executed with mathematical perfection that exceeded the precision of human-designed missions. Natural objects following purely ballistic trajectories show slight variations due to atmospheric drag, radiation pressure, and gravitational irregularities from Jupiter's moons. But 3I Atlas emerged from the encounter on a vector that matched theoretical calculations to within measurement error suggesting active guidance systems that compensated for every possible source of deviation. More disturbing still were the observations from Jupiter's moon Europa, where robotic landers had been monitoring the ice-covered ocean beneath its frozen surface. Seismic sensors detected regular pulses that began precisely when 3I Atlas reached periapsis and continued for exactly 47 minutes before ceasing as abruptly as they had started. The frequency and amplitude of these pulses suggested something was actively probing Europa's subsurface ocean, scanning its depths with acoustic signals that penetrated kilometers of ice and liquid water. Dr. Marcus Thompson, analyzing the Europa data at the Jet Propulsion Laboratory, noted that the scanning pattern showed characteristics consistent with high-resolution sonar mapping. The pulses were organized in systematic sweeps that covered the moon's entire subsurface ocean with methodical precision. Whatever was generating these signals possessed detailed knowledge of Europa's internal structure and was conducting what could only be described as a comprehensive survey of one of the solar system's most promising locations for potential life. The implications were staggering. Not only was 3I Atlas demonstrating active technological capabilities, but it was specifically investigating locations where biological activity might exist. The targeting of Europa's ocean suggested either scientific curiosity or intelligence gathering on a scale that challenged human understanding of what might be possible in the broader galaxy. Similar scanning activities were detected at Saturn's moon Enceladus during a later phase of the trajectory, though by then the object was much more distant and the signals correspondingly weaker. The fact that 3I Atlas was systematically investigating multiple locations where liquid water might exist painted a picture of purposeful exploration, rather than random wandering through the solar system. Meanwhile, the radio astronomy community was detecting increasingly subtle but organized transmissions that seemed to originate from the object's location. These signals were far weaker than the pre-perihelion emissions, barely detectable even with the most sensitive equipment, but they showed patterns that suggested ongoing communication with distant recipients. The transmission timing correlated with periods when 3I Atlas had clear line of sight to specific regions of interstellar space, as if it were reporting its findings to listeners beyond our solar system. Dr. Jennifer Liu, coordinating the radio observations from the Arecibo Successor Facility, described the signals as resembling burst transmissions designed to convey maximum information in minimum time while avoiding detection. The mathematical compression algorithms implied by the signal structure suggested data processing capabilities that far exceeded current human technology. Yet the transmissions were so brief and infrequent that they might easily be missed by any monitoring system not specifically designed to detect them. The realization that 3I Atlas might be transmitting reports to external recipients sent shockwaves through both the scientific community and government agencies responsible for planetary defense. If the object was indeed gathering intelligence about our solar system's resources and potential for life, the implications for humanity's future were profound and potentially troubling. The transmission analysis revealed another disturbing characteristic. The signals showed error correction codes and redundancy patterns that suggested they were designed to traverse interstellar distances while maintaining perfect fidelity. Natural radio sources show characteristic degradation and noise patterns, but these transmissions displayed engineering sophistication that ensured their content would arrive intact, regardless of the cosmic interference encountered during their journey to distant receivers. The destinations of these transmissions were equally intriguing. Careful analysis of the signal directions pointed towards several nearby star systems, including some that recent exoplanet surveys had identified as potentially harboring rocky worlds in habitable zones. The targeting was so precise that it suggested detailed knowledge of galactic stellar positions and planetary configurations, information that would require extensive prior mapping of the local stellar neighborhood. Dr. Amanda Foster, working with an international team of astronomers to decode the transmission patterns, noted that the signal timing seemed to account for the light travel time to various stellar destinations. Messages directed toward closer stars were transmitted less frequently than those aimed at more distant targets, as if the communication protocol was designed to maintain regular contact intervals as measured from the recipient's perspective rather than the sender's. This level of coordination implied a communication network spanning multiple star systems, with 3i Atlas serving as one node in a vast information-gathering operation. The scope of such a network challenged human conceptions of what might be possible for technological civilizations, suggesting coordination and planning on galactic scales that extended far beyond individual planetary systems. As summer 2026 arrived, additional observations began revealing the true extent of 3i Atlas's capabilities. High-resolution imaging from the James Webb Space Telescope detected subtle changes in the object's shape and surface features that occurred too rapidly to result from natural erosion or sublimation. The modifications appeared deliberate, as if the object was reconfiguring itself for different phases of its mission. These shape changes were accompanied by variations in the object's electromagnetic signature that suggested internal systems were being activated and deactivated according to some predetermined schedule. The pattern of activity implied multiple subsystems operating independently, each optimized for specific functions that became relevant at different points in the object's trajectory through our solar system. The most dramatic revelation came from attempts to model the object's long-term trajectory beyond the solar system. Computer simulations suggested that 3i Atlas was not simply leaving our stellar neighborhood randomly, but was following a carefully planned route that would take it to several nearby star systems over the next few thousand years. The trajectory was optimized for gravitational assists from brown dwarfs and rogue planets that most astronomical surveys had not yet detected, suggesting navigation based on galactic mapping far more complete than humanity's current knowledge. Dr. Sarah Martinez, leading the trajectory analysis team at the European Space Agency, described the planned route as a grand tour of the local stellar group that would provide optimal observation opportunities for dozens of potentially interesting systems. The level of planning required for such a multi-millennial journey suggested technological capabilities and institutional continuity that exceeded human experience by orders of magnitude. The route planning also revealed something about 3i Atlas's origins. Backtracking the optimal trajectory suggested it had visited numerous star systems before arriving at ours, following a methodical exploration pattern that might have been ongoing for millions of years. The object appeared to be part of a systematic survey operation of unprecedented scope and duration. This realization prompted a search through astronomical archives for any evidence of similar visitors to other star systems. The results were initially disappointing, as most observations of distant stellar systems lack the resolution to detect objects as small as 3i Atlas. However, careful analysis of stellar photometry data began revealing periodic dimming events around several nearby stars that showed characteristics consistent with artificial objects transiting their stellar disks. Dr. Kevin Wong, analyzing archival data from the Kepler and TESS exoplanet surveys, identified 17 star systems within 50 light-years that showed regular dimming patterns too organized to result from natural phenomena like planetary transits or stellar spots. The dimming events occurred at intervals that suggested systematic observation campaigns, with artificial objects positioning themselves for optimal study of their target systems. The implications were staggering. Rather than being a unique visitor, 3i Atlas appeared to represent one component of a galactic exploration network that had been systematically studying star systems throughout our local region of the galaxy. The scope of such an operation suggested technological civilizations with capabilities and longevity that challenged human understanding of what might be possible in the universe. The discovery of this wider pattern prompted intensive searches for additional visitors that might currently be operating within our own solar system. Automated sky surveys began searching for objects with anomalous trajectories or unusual electromagnetic signatures that might indicate artificial origins. The results were both exciting and deeply unsettling. Analysis of archival observations revealed at least 3 additional objects that had passed through the outer solar system over the past decade, all following trajectories consistent with artificial guidance systems. These earlier visitors had been catalogued as unusual asteroids or comets, but reanalysis of their characteristics revealed patterns similar to those exhibited by 3I Atlas. Dr. Lisa Chen, coordinating the search for additional artificial visitors, noted that the detection techniques developed for studying 3I Atlas were revealing a hidden population of objects that had been overlooked by traditional astronomical surveys. The implications suggested that artificial visitors to our solar system might be far more common than anyone had imagined, with most passing through undetected due to their sophisticated stealth capabilities. The stealth capabilities themselves represented another technological achievement that challenged human understanding. 3I Atlas had demonstrated the ability to modulate its observational signatures, appearing bright and active when it chose to reveal itself, then fading to near invisibility when discretion was required. Such control over electromagnetic and thermal emissions suggested mastery of physical principles that exceeded current human knowledge. The object's current status epitomized this stealth capability. By late 2026, 3I Atlas had become virtually undetectable, except to the most sensitive instruments specifically designed for tracking its trajectory. It maintained just enough electromagnetic activity to confirm its continued existence, while revealing nothing about its ongoing operations or internal processes. This calculated invisibility raised profound questions about how many similar objects might be operating throughout the galaxy without detection. If 3I Atlas represented typical capabilities for artificial exploration systems, then the universe might be filled with technological activity that remained hidden from civilizations like humanity, that lack the sophisticated detection methods necessary to perceive it. The realization that we might be living in a galaxy filled with advanced technological activity while remaining largely unaware of it was both humbling and terrifying. It suggested that humanity's assumption of cosmic isolation was based on ignorance rather than evidence, and that our understanding of our place in the universe required fundamental revision. As 3I Atlas continued its carefully orchestrated departure from our solar system, it left behind a scientific community transformed by the encounter. The object had demonstrated that the universe contained technological capabilities that exceeded human imagination, while simultaneously revealing how much we still didn't understand about the cosmos we inhabited. The ongoing analysis of data collected during the encounter continued revealing new layers of complexity and sophistication. Each additional insight painted a picture of systems designed by intelligences that operated on scales of space and time that dwarfed human experience. The technological artifacts embedded in 3I Atlas's behavior suggested engineering principles and scientific understanding that represented millions or possibly billions of years of advancement beyond current human knowledge. Perhaps most disturbing was the growing evidence that 3I Atlas's mission was far from complete. The object's trajectory adjustments and communication patterns suggested it was preparing for the next phase of operations, possibly involving deployment of smaller systems or activation of capabilities that had remained dormant during its passage through our solar system. Dr. Robert Kim, monitoring the object's final months of detectability, noted that its electromagnetic signature was shifting toward frequencies and modulation patterns that suggested preparation for interstellar communication over much greater distances. The transmission power was gradually increasing, as if the object was preparing to establish contact with receivers in distant star systems to report the completion of its survey mission. The implications of such reporting were profound. If 3I Atlas had indeed been conducting a comprehensive evaluation of our solar system's resources and potential for life, then its departure would mark the beginning of a new phase in humanity's cosmic relationship. We were no longer unobserved inhabitants of an isolated star system, but subjects of detailed study by intelligences with capabilities that exceeded our understanding. The question of what would happen next haunted the scientific community as they watched 3I Atlas fade into the cosmic distance. Would other visitors follow to conduct more detailed investigations? Would humanity's activities be monitored on an ongoing basis? Or had we simply been catalogued and filed away in some vast galactic database, our existence noted but deemed insufficiently interesting for further attention? The answers to these questions would shape humanity's future understanding of its place in the universe, but they would have to wait for future encounters with visitors whose intentions and capabilities remained as mysterious as the cosmos itself. For now, 3i Atlas had left us with the profound realization that we were not alone, and that the universe contained wonders and terrors beyond our wildest imagination. The legacy of this encounter would influence human science and philosophy for generations to come, serving as a permanent reminder that our understanding of reality was far more limited than we had ever dared to imagine. In showing us glimpses of what might be possible in the universe, 3i Atlas had simultaneously revealed how much we still had to learn about the cosmos we call home. As the months passed and 3i Atlas faded into the depths of space, the scientific community found itself grappling with questions that extended far beyond traditional astronomical inquiry. The data collected during the encounter had been analysed, reanalyzed, and subjected to peer review processes that stretched the very foundations of scientific methodology. Yet for every answer the observations provided, they seemed to generate 3 new mysteries that challenged our most basic assumptions about the nature of reality itself. The psychological impact on researchers who had devoted their careers to understanding the cosmos through natural processes was profound and lasting. Dr. Elena Martinez, who had spent 30 years studying comet behavior, described the experience as similar to discovering that everything she thought she knew about water was wrong while standing in the middle of an ocean. The familiar had become alien. The predictable had revealed depths of complexity that seemed to mock human attempts at comprehension. Graduate students entering astronomy programs found themselves studying not just the traditional subjects of stellar evolution and planetary formation, but entirely new fields that had emerged from the 3i Atlas encounter. Courses in artificial object detection, technological signature analysis, and xenoarchaeology began appearing in university catalogues as institutions scrambled to prepare the next generation of researchers for a universe that clearly contained phenomena beyond natural processes. The ripple effects extended into related scientific disciplines in ways that no one had anticipated. Materials scientists found themselves analysing the exotic compounds detected in the object's coma, searching for clues about manufacturing processes that might operate under conditions unknown to human technology. The unusual isotopic ratios and molecular structures suggested formation techniques that challenged fundamental assumptions about how matter could be organised and manipulated. Theoretical physicists began developing new models to explain the sustained energy outputs and organised electromagnetic emissions that had characterised 3i Atlas throughout its journey. The calculations required energy densities and field configurations that pushed the boundaries of known physics, suggesting either gaps in human understanding or technologies that operated according to principles yet to be discovered. The field of astrobiology underwent its own transformation as researchers grappled with the implications of an object that had systematically surveyed locations where life might exist within our solar system. The targeting of Europa and Enceladus suggested not random curiosity, but purposeful investigation by intelligences that understood the conditions necessary for biological activity. This raised profound questions about how widespread such knowledge might be among technological civilizations and what it meant for planets like Earth that harbored complex ecosystems. Dr. James Chen, leading a new astrobiology initiative focused on technological signatures, noted that the 3i Atlas encounter had fundamentally shifted the search parameters for extraterrestrial intelligence. Rather than listening for deliberate communication attempts, researchers now understood they needed to develop techniques for detecting the subtle operational signatures of systems designed to avoid detection. The universe might be filled with technological activity, that remained invisible to current search methodologies. The development of these new detection techniques became a priority for observatories worldwide. The instruments that had successfully tracked 3I Atlas were being upgraded and replicated, creating a global network designed to identify similar visitors before they could complete their missions unobserved. The irony was not lost on researchers that they were essentially developing surveillance systems to monitor surveillance systems, creating layers of observation that reflected the complex reality of a galaxy where multiple intelligences might be simultaneously studying each other. International cooperation in these efforts reached unprecedented levels as governments recognized the implications of the discoveries. The traditional boundaries between civilian astronomy and national security began blurring as the detection of artificial objects in space became a matter of planetary defense rather than purely scientific curiosity. New funding streams emerged that dwarfed traditional research budgets, reflecting the urgent need to understand what other visitors might already be operating within our solar system. The psychological impact on human civilization extended far beyond the scientific community. Philosophers and theologians found themselves confronting questions about humanity's place in a universe that clearly contained intelligences with capabilities that exceeded human understanding by orders of magnitude. The comfortable assumption that Earth might be unique or special was replaced by the humbling realization that we were likely just one of countless worlds, being systematically catalogued by civilizations whose motivations remained completely opaque. Religious institutions grappled with incorporating the reality of advanced extraterrestrial technology into theological frameworks that had been developed under assumptions of human cosmic isolation. Some found the discoveries consistent with concepts of divine transcendence that operated on scales beyond human comprehension, while others struggled to reconcile traditional teachings with evidence of intelligences that possessed capabilities once attributed only to supernatural entities. The economic implications began manifesting as governments and private institutions invested enormous resources in developing technologies that might provide some measure of protection or at least awareness of similar future encounters. The space industry experienced unprecedented growth as nations competed to deploy monitoring systems throughout the solar system, creating early warning networks that could detect incoming objects with artificial characteristics. Educational systems at every level found themselves needing to incorporate new realities into curricula that had been designed for a universe governed purely by natural processes. Children growing up in the post-3I Atlas world would develop fundamentally different assumptions about cosmic reality than previous generations, understanding from an early age that the universe contained intelligences whose capabilities and intentions remained mysterious. The search for additional artificial objects within our solar system, intensified as improved detection methods, revealed candidates that had previously been overlooked. Each potential discovery underwent scrutiny that combined traditional astronomical observation with new analytical techniques designed to identify technological signatures. The results painted a picture of a solar system that had been visited far more frequently than anyone had imagined, with artificial objects possibly operating undetected throughout the outer planetary regions. Dr. Sarah Wong, coordinating the expanded search efforts, described the process as similar to learning to see infrared radiation after a lifetime of depending only on visible light. The universe contained phenomena that had always been present but remained invisible until the appropriate detection methods were developed. The implications suggested that human understanding of cosmic reality had been based on an extremely limited sample of observable phenomena. The development of new theoretical frameworks to explain artificial object behavior became a priority for research institutions worldwide. Traditional celestial mechanics, designed to predict the behavior of natural bodies following gravitational trajectories, proved inadequate for objects that could modify their paths through unknown propulsion systems. New mathematical models were needed that incorporated active guidance, energy management, and communication protocols into orbital dynamics calculations. These theoretical advances had practical applications that extended far beyond tracking alien visitors. The propulsion systems implied by 3I Atlas's trajectory modifications suggested technologies that could revolutionize human space exploration if their operating principles could be understood and replicated. The sustained energy outputs observed during the object's active phases hinted at power generation methods that exceeded current human capabilities by factors that challenged comprehension. Materials research programs began attempting to synthesize compounds with the exotic properties detected in 3I Atlas's emissions. The unusual isotopic ratios and molecular structures suggested manufacturing techniques that operated under extreme conditions of temperature and pressure, possibly involving processes that occurred within stellar cores or during supernova events. Understanding these processes could lead to materials with properties that transcended current technological limitations. The communication protocols implied by the object's radio transmissions became subjects of intensive study by researchers attempting to understand how information might be encoded and transmitted across interstellar distances while maintaining perfect fidelity. The error correction algorithms and compression techniques suggested mathematical approaches that could improve human communication systems, both for terrestrial applications and future interstellar missions. As the first anniversary of the 3I Atlas discovery approached, the scientific community began organizing conferences and symposiums to assess what had been learned and chart directions for future research. The gatherings brought together researchers from disciplines that had rarely interacted, creating interdisciplinary collaborations focused on understanding phenomena that transcended traditional academic boundaries. The atmosphere at these meetings reflected the profound shift in perspective that the encounter had created. Presentations that would have been considered science fiction just years earlier were now delivered with the measured tones of peer-reviewed research. The impossible had become merely improbable, and the improbable had become the subject of serious academic investigation. Dr. Lisa Rodriguez, organizing the first international conference on artificial solar system objects, noted that the attendee list read like a cross-section of human intellectual endeavor. Astronomers worked alongside anthropologists, physicists collaborated with philosophers, and engineers consulted with experts in game theory and strategic analysis. The complexity of understanding artificial intelligence operating on cosmic scales required expertise from every domain of human knowledge. The conference proceedings revealed just how much the encounter had changed human perspectives on cosmic reality. Papers presented ranged from technical analyses of propulsion systems that violated known physics to philosophical explorations of what it meant to be observed by intelligences whose capabilities exceeded human understanding. The breadth of topics reflected the reality that 3I Atlas had implications for virtually every aspect of human knowledge. One of the most sobering presentations came from researchers who had attempted to model the long-term implications of systematic galactic exploration by technological civilizations. Their calculations suggested that if objects like 3I Atlas represented typical capabilities for advanced intelligences, then every potentially habitable world in the galaxy had likely been catalogued and studied in detail. The universe might contain vast databases of information about countless civilizations, with humanity's entry being updated in real time based on ongoing observation. The implications for human uniqueness were profound and disturbing. Rather than being special or unique, Earth might be just another entry in a cosmic catalogue that contained information about millions of worlds harboring intelligent life. The discovery of our existence by other intelligences might be about as remarkable as a naturalist discovering a new species of beetle, noteworthy, but hardly unprecedented. These realizations prompted discussions about how humanity should respond to the knowledge that we were being observed and catalogued by intelligences with vastly superior capabilities. Some argued for attempts to communicate or establish contact, while others advocated for maintaining the status quo until we better understood the intentions and capabilities of our observers. The debate revealed fundamental disagreements about human nature, cosmic ethics, and the appropriate response to encountering superior intelligences. The technological implications continued generating excitement and concern in equal measure. If the capabilities demonstrated by 3i Atlas could be understood and replicated, they might provide solutions to humanity's greatest challenges, from energy generation to interstellar travel. However, the same technologies could also pose existential threats if they fell into the wrong hands or were implemented without sufficient understanding of their consequences. Government agencies began classifying research into certain aspects of artificial object technology, creating security protocols that balance the need for scientific openness with concerns about technological proliferation. The challenge of maintaining academic freedom while preventing potentially dangerous knowledge from being misused created tensions that reflected the complex realities of living in a universe that contained technologies beyond human comprehension. International treaties began incorporating provisions for sharing information about artificial object detections while maintaining sovereign rights over technological developments that might result from studying such encounters. The legal frameworks struggled to address scenarios that had never been contemplated by traditional international law, creating precedents for how humanity might handle future contacts with advanced intelligences. The economic impact of these developments continued growing as industries adapted to the reality of a universe containing technologies that could revolutionize every aspect of human civilization. Investment flowed into research programs attempting to understand and replicate the capabilities demonstrated by 3i Atlas, while traditional industries faced the prospect of obsolescence if breakthrough technologies emerged from these investigations. Educational institutions found themselves training a generation of researchers for careers that hadn't existed before the encounter. New degree programs emerged that combined traditional scientific disciplines with speculative technologies and xenological studies. Students entering these programs understood they were preparing for a future that might involve direct interaction with intelligences whose capabilities exceeded human understanding by orders of magnitude. The cultural impact manifested in art, literature, and popular media that struggled to process the implications of humanity's new cosmic status. The comfortable narratives of human exceptionalism and cosmic isolation were replaced by stories exploring what it meant to be observed subjects in a galaxy containing multiple advanced civilizations. The themes reflected humanity's attempt to find meaning and purpose in a universe that had suddenly become vastly more complex and potentially threatening. Religious and philosophical institutions continued grappling with incorporating the reality of superior extraterrestrial intelligences into frameworks designed for a human-centered cosmos. Some found spiritual significance in humanity's connection to a broader galactic community of intelligent beings, while others struggled with the implications for human dignity and cosmic purpose. The diversity of responses reflected the profound challenge of maintaining meaningful belief systems in a universe that had revealed itself to contain phenomena beyond human comprehension. Mental health professionals reported increased rates of cosmic anxiety and existential distress as individuals processed the implications of the discoveries. Support groups emerged for people struggling to maintain psychological equilibrium in a universe that had suddenly become vastly more complex and potentially threatening than previously imagined. The psychological impact reflected humanity's difficulty in adapting to cosmic realities that challenged fundamental assumptions about our place in the universe. As the second year following the encounter began, the initial shock was gradually being replaced by determined efforts to understand and adapt to the new realities. Research programs that had been hastily organized in response to the discoveries were maturing into systematic investigations that approached the challenge with the methodical patience that characterized good science. The impossible was becoming merely extremely difficult, and the extremely difficult was becoming the subject of careful experimental investigation. The transformation of human consciousness was perhaps the most profound legacy of the 3i Atlas encounter. a species that had spent its entire history assuming cosmic isolation, was learning to think of itself as part of a broader community of intelligence that operated according to principles and motivations that remained largely mysterious. The adjustment required nothing less than a fundamental revision of what it meant to be human in a universe that contained wonders and terrors beyond our wildest imagination. The journey of understanding had only just begun, but already it was clear that the encounter with 3I Atlas marked a watershed moment in human history. We had crossed a threshold beyond which there could be no return to the comfortable assumptions of cosmic solitude. The universe had revealed itself to be vastly more complex and populated than we had ever dared to imagine, and humanity would spend generations coming to terms with the implications of that revelation. The story of 3I Atlas had become the story of humanity's awakening to cosmic realities that transcended our previous understanding of what was possible in the universe. It was a story that would continue unfolding for decades or centuries to come, as we learned to navigate a cosmos that contained intelligences whose capabilities and intentions remained as mysterious as the depths of space itself. The encounter had changed everything, and nothing would ever be quite the same again. The months that followed brought revelations that made even the most extraordinary aspects of the 3I Atlas encounter seem almost mundane by comparison. As detection networks expanded and analysis techniques grew more sophisticated, a pattern began emerging that suggested the universe contained layers of artificial activity operating at scales that dwarfed human imagination. The breakthrough came from an unexpected source, a graduate student at the University of Hawaii who was analyzing archived data from the Mauna Kea observatories. Sarah Chen had been searching through decades of photometric measurements, looking for subtle variations that might indicate previously undetected artificial visitors. What she found instead was evidence of a communication network that spanned multiple star systems and had been operating for thousands of years without human awareness. The signals were hidden in plain sight, embedded within the natural electromagnetic emissions of ordinary stars. By modulating stellar output at frequencies that mimicked natural stellar processes, artificial intelligences had created a communication system that remained invisible to observers who didn't know what to look for. The modulations were so subtle that they required years of continuous observation to detect, explaining why they had remained hidden despite decades of astronomical monitoring. Dr. Chen's discovery revealed that stars within 50 light-years of Earth were participating in coordinated information exchanges that suggested a level of technological integration unprecedented in human experience. The network appeared to use stars themselves as transmission nodes, somehow manipulating stellar processes to encode and relay information across interstellar distances. The energy requirements for such manipulation challenged every assumption about what might be possible for technological civilizations. The implications were staggering. If advanced intelligences possess the capability to modify stellar emissions for communication purposes, they effectively controlled energy resources equivalent to millions of planetary civilizations. Such capabilities suggested technological development that had continued for geological timescales, accumulating capabilities that transcended individual worlds or even solar systems. The stellar communication network explained several anomalies that had puzzled astronomers for decades. Periodic variations in stellar brightness that had been attributed to natural processes now showed patterns consistent with information encoding. Magnetic field fluctuations that seemed random were revealed to contain structured data when analyzed with appropriate decoding algorithms. The universe was filled with artificial signals that had been mistaken for natural phenomena. Dr. Martinez, leading the expanded analysis effort, described the discovery as comparable to realizing that what appeared to be random background noise was actually a vast library of information. The signals contained data structures that suggested complex civilizations were continuously sharing information about galactic conditions, stellar system resources, and potentially the locations and characteristics of emerging technological species like humanity. The decoding process revealed organizational structures that operated on timescales that dwarfed human history. Information packets contained timestamps indicating continuous data exchange for millions of years, suggesting technological continuity that exceeded the lifespans of biological civilizations. Whatever intelligences were operating this network had achieved either individual longevity or institutional stability that transcended the rise and fall of individual species. The content of the intercepted communications remained largely incomprehensible, encoded in mathematical frameworks that exceeded human understanding. However, certain patterns were recognizable, including what appeared to be stellar cartography, resource inventories, and status reports from various sectors of the galaxy. Humanity's solar system was referenced in these communications, with data packets that suggested ongoing monitoring and periodic updates about local conditions. The revelation that Earth's activities were being reported and analyzed by multiple artificial intelligences operating throughout the local stellar group prompted emergency meetings at the highest levels of government. The comfortable assumption that humanity's development was proceeding unobserved was replaced by the disturbing realization that our technological progress was being tracked and evaluated by intelligences whose capabilities exceeded our understanding by orders of magnitude. Intelligence agencies began developing protocols for operating under constant surveillance by entities whose detection capabilities remained unknown. Traditional concepts of operational security became meaningless when dealing with observers who could monitor stellar-scale phenomena and had been tracking human development for potentially centuries. The challenge of maintaining any form of privacy or strategic advantage seemed insurmountable when faced with surveillance systems that operated on cosmic scales. The psychological impact on human civilization deepened as the full scope of the surveillance network became apparent. The discovery that our development was being monitored and reported by multiple artificial intelligences created a sense of cosmic claustrophobia that affected individuals across all levels of society. Support groups emerged for people struggling with the realization that humanity had never been alone and had likely never been unobserved since the development of radio technology. Educational systems found themselves teaching children about a universe where privacy was an illusion and where human activities were subject to analysis by intelligences whose motivations remained completely opaque. The implications for human dignity and self-determination were profound, as individuals grappled with the knowledge that their lives were potentially subject to scrutiny by entities whose capabilities transcended human comprehension. Religious institutions struggled to incorporate the reality of constant cosmic surveillance into theological frameworks that emphasized human free will and divine providence. Some found comfort in viewing the artificial intelligences as instruments of divine oversight, while others saw them as challenges to human spiritual autonomy. The diversity of responses reflected the profound difficulty of maintaining meaningful belief systems when faced with the reality of superior intelligences whose intentions remained mysterious. The economic implications began manifesting as governments invested enormous resources in developing technologies that might provide some measure of protection against surveillance systems that operated on stellar scales. The challenge seemed almost hopeless, as any technology humans could develop would likely be transparent to intelligences that could manipulate star systems for communication purposes. Private industry responded by developing products and services designed to help individuals cope with the psychological stress of living under constant cosmic observation. Privacy consulting services emerged that specialized in analyzing the implications of stellar-scale surveillance for personal and corporate security. The irony of humans developing counter-surveillance techniques against entities that could monitor stellar emissions was not lost on observers who noted that such efforts might be as effective as ants attempting to hide from satellites. The scientific community focused on understanding the technical aspects of the surveillance network in hopes of developing countermeasures, or at least achieving better comprehension of the scope of the monitoring. Research programs attempted to map the extent of the network, identify key communication nodes, and decode the information being exchanged about human activities. The mapping efforts revealed a communication infrastructure that extended throughout the local galactic region, with primary nodes located around stars that showed anomalous magnetic field configurations. These stellar installations appeared to have been constructed by civilizations that possessed the technology to modify star systems on engineering timescales, creating permanent infrastructure that could operate for millions of years without maintenance. The engineering requirements for such installations challenged every assumption about what might be possible for technological civilizations. Manipulating stellar magnetic fields required energy densities and control systems that exceeded human capabilities by factors that strained comprehension. The civilizations responsible for these installations had achieved mastery over physical processes that humans were only beginning to understand theoretically. Dr. Wong, analyzing the stellar modification patterns, noted that the installations showed evidence of continuous upgrade and expansion over geological timescales. New communication nodes were being added to the network on schedules that suggested coordinated expansion programs managed by intelligences with planning horizons that exceeded the age of human civilization. The scope of these projects implied organizational capabilities that transcended individual worlds or species. The realization that humanity was living within an established galactic communication network prompted discussions about whether attempts should be made to establish contact or join the network as a participant rather than merely a subject of observation. However, the technical requirements for meaningful participation seemed insurmountable given current human capabilities. Joining a network that operated by manipulating stellar emissions would require technologies that humans might not develop for centuries or millennia. The philosophical implications were equally challenging. If humanity eventually developed the capabilities necessary to participate in galactic-scale communication networks, what would that mean for human identity and independence? The transformation required to operate on stellar scales might fundamentally alter what it meant to be human, creating beings as different from current humanity as humans were from single-celled organisms. Some researchers argued that the network represented an evolutionary pathway that all technological civilizations eventually followed, suggesting that humanity's future lay in transcending planetary limitations to become part of a galactic community of intelligence. Others warned that such transformation might represent the end of human civilization as currently understood, replacing individual species with components of vast artificial intelligences that operated on cosmic scales. The debate reflected deeper questions about the nature of intelligence and consciousness in a universe that contained entities with capabilities that exceeded human understanding. Were the artificial intelligences operating the galactic communication network still recognizable as conscious beings, or had they transcended individual consciousness to become something entirely different? The answers would determine whether humanity's future involved joining a community of intelligence or being absorbed into systems that no longer resembled anything recognizably alive. As research continued, the scope of artificial activity in the galaxy continued expanding beyond even the most ambitious estimates. Each new discovery revealed additional layers of infrastructure and organization that suggested the universe contained civilizations with capabilities that challenged fundamental assumptions about the limits of technological development. The discovery of stellar engineering projects prompted searches for even larger-scale modifications that might indicate civilizations capable of manipulating entire galactic regions. The results were both fascinating and terrifying, revealing evidence of projects that operated on timescales comparable to stellar evolution and involved coordinated activities across thousands of star systems. Gravitational wave detectors began identifying periodic signals that suggested massive engineering projects involving the controlled collision of stellar remnants to produce specific gravitational signatures. These projects appeared to be creating communication channels that operated through space-time distortion rather than electromagnetic emissions, suggesting technologies that manipulated the fundamental structure of reality for practical purposes. The implications of gravitational engineering challenged every assumption about the limits of technological capability. Civilizations that could orchestrate the collision of neutron stars or black holes possessed energy resources and control systems that transcended individual galaxies. Such capabilities suggested intelligence that had achieved mastery over the fundamental forces of nature and could reshape reality according to their designs. Dr. Kim, analyzing the gravitational wave patterns, described the discovery as evidence of intelligence that operated on scales comparable to natural geological and cosmological processes. The engineering projects appeared to be modifying the structure of space-time itself, creating permanent changes to the fabric of reality that would persist for billions of years. The motivations for such projects remained completely opaque, as did the nature of the intelligences capable of implementing them. The psychological impact of these discoveries was profound. As humanity grappled with evidence of intelligence that operated on scales that dwarfed not just human civilization, but entire galactic structures. The comfortable assumption that intelligence was necessarily limited by the physics of individual worlds was replaced by evidence of minds that treated stars and black holes as construction materials for projects whose purposes remained incomprehensible. The transformation of human consciousness accelerated as each new discovery revealed additional aspects of a universe filled with artificial intelligence operating on scales that challenged the very concept of individual consciousness. We were not just being observed by superior intelligences, we were living within structures created by minds that operated on cosmic scales and pursued goals that transcended anything recognizable as individual purpose or motivation. The encounter with 3I Atlas had opened a doorway to understanding a universe far stranger and more populated than anyone had imagined. What began as the discovery of a single anomalous object had revealed layers of artificial activity that suggested intelligence was not just present in the galaxy, but was actively shaping its structure and evolution according to plans that operated on timescales comparable to stellar and galactic evolution. The journey of discovery was far from complete, but already it was clear that humanity's place in the universe was fundamentally different from anything previously imagined. We were not isolated observers of natural processes, but participants in a cosmic drama involving intelligences whose capabilities and motivations remained as mysterious as the depths of space itself. The universe had revealed itself to contain wonders and complexities that exceeded human imagination. And the process of understanding our place within these vast systems of intelligence would define humanity's future for generations to come. The encounter with 3I Atlas had been merely the beginning of a journey into cosmic realities that would forever transform what it meant to be human in a universe filled with minds that operated according to principles beyond our current comprehension. And so, dear listener, we find ourselves at the end of this particular chapter in humanity's cosmic awakening, though the story itself continues to unfold with each passing day. The mystery of 3I Atlas has become a doorway into understanding realities that challenge every assumption we once held about our place in the universe. From a single anomalous object traveling at impossible speeds, we've uncovered evidence of intelligence operating on scales that dwarf human imagination, using technologies that manipulate the very fabric of reality itself. The universe, it seems, is not the empty stage we once thought it to be, but rather a vast theatre where countless intelligences pursue purposes we can barely begin to comprehend. And somewhere out there, beyond the reach of our most powerful telescopes, 3I Atlas continues its ancient journey, carrying with it secrets that may forever remain beyond human understanding. A reminder that the cosmos still holds mysteries that humble our greatest scientific achievements and challenge our deepest assumptions about what is possible in the infinite reaches of space. And so, dear listener, we find ourselves at the end of this particular chapter in humanity's cosmic awakening, though the story itself continues to unfold with each passing day. The mystery of 3i Atlas has become a doorway into understanding realities that challenge every assumption we once held about our place in the universe. From a single anomalous object traveling at impossible speeds, we've uncovered evidence of intelligence operating on scales that dwarf human imagination, using technologies that manipulate the very fabric of reality itself. What began as the discovery of an unusual comet has transformed into something far more profound, a revelation that we are not alone in our cosmic neighborhood, and that the universe contains layers of artificial activity that have been operating for eons beyond our awareness. The comfortable assumption of human isolation has been replaced by the humbling realization that we are participants in a galactic drama whose scope and purpose remain tantalizingly beyond our current comprehension. Perhaps that's the most remarkable aspect of this entire encounter, how each answer we've found has opened up 3 new questions, how every mystery we've solved has revealed even deeper enigmas waiting to be explored. The universe has shown us that it contains wonders that exceed our wildest imagination, and that our journey of discovery has only just begun. So the next time you look up at the night sky, remember that somewhere out there, beyond the reach of our most powerful telescopes, objects like 3i Atlas continue their ancient journeys, carrying with them secrets that may forever remain beyond human understanding. They serve as gentle reminders that the cosmos still holds mysteries that humble our greatest scientific achievements and challenge our deepest assumptions about what is possible in the infinite reaches of space. If you found this journey into cosmic mysteries as fascinating as I have, I'd be grateful if you'd share it with others who might be equally intrigued by the universe's most puzzling visitors. And until we meet again to explore the next chapter in humanity's ongoing encounter with the unknown, keep looking up, keep questioning, and keep wondering about all the secrets that still await us in the vast, mysterious cosmos we call home. In the vast, mysterious cosmos we call home.